Hi guys, welcome to ECE 111. Welcome to week one. I'm so glad you're here. Today we're going to go over a little bit about chapter 11 for our week one content. So chapter 11 is cognitive development through the curriculum, and we're going to start by going over three different cognitive development theories just as a basis to how children develop the ability to think and learn and grow. And we know that's an amazing process. First, let's look at Piaget's theory of cognitive development. Of course, Piaget felt that this development happened in stages. So 4 different basic stages: sensory motor, pre-operational, concrete operational, and formal operational. So let's look at the first one, sensory motor. This is about the age of birth to 2 years. So basically, the child understands the world through their senses and actions. And to think of an example of that, I want you to think of an infant, and they are understanding the world through what they feel, what they see, how the foods that they're fed, their surrounding environment. So any of these things that come in through their senses, their hearing, their sight, their taste, is helping them understand their world. So it's important that we pay attention to this. In the pre-operational stage, this is about 2 to 7 years old. Now, it's important to note that these ages aren't set in stone. It can vary child to child. Some may progress more quickly, whereas others more slowly. They need a little more time. So approximately 2 to 7 is the pre-operational stage, according to Piaget. Understands the world through language, the words that they hear in their environment, the words that are spoke to them by parents, by caregivers, and also through their mental images, what they come up with in their own little brains. And something we notice at this stage, 2 to 7 years old, is sometimes when nightmares can kick in. So this would be an example of a kind of a negative mental image. The good news is, as parents and as caregivers, we have somewhat of a control over the images that we let our children see and the things that we let them be around. And it's really important from 2 to 7 that they be a little more sheltered. They don't need to see that scary movie. Even at 2 years old, that's being registered in their brain. So save those for later on where they can enjoy them and it won't create possible nightmares. Also, next, concrete operational, approximately 7 to 12 years old, understands the world through logical thinking and categories. So they categorize their learning into like science, math, school, home, all the different areas they might be, and the items that they are encountering in their brains are being put into logical categories. So we want to remember that. Now, in early childhood, we don't do a lot. With 7 and 8-year-olds, you might be, for instance, a teaching assistant in a 3rd grade classroom, and that chance you would. But you need to remember that they're very logical and that they're categorizing things. So along with the being very logical, you have to remember in the classroom that they really don't understand sarcasm at this point. And sometimes as adults, we can use sarcasm on a pretty regular basis. So this is one thing we want to leave in the back seat until the end of the day, and not use around this age group so much. Okay, next, formal operational, 12 years old and onward. Again, not so much our age group, but they're understanding the world through hypothetical thinking and through scientific reasoning. So their cognitive development is continuing to increase and their thought processes are continuing to deepen. Next, behaviorism is a cognitive development theory developed by B.F. Skinner. And it's very relevant in the area of behavior management. So Basically, if you change a child's behavior by systematically managing the consequences, you can either increase the chances of those good consequences, those good processes, or we might increase the chances of those bad behaviors if we reward bad behavior. So what we want to do instead is we want to give good consequences. We want to give rewards for a child doing the right thing, whether that be a physical reward like a sticker or a verbal reward with just attention and praise. So we are increasing the chances of that good behavior reoccurring if we reinforce it positively. On the other hand, we may have a bad consequence for a negative behavior. And the purpose of that is we want that behavior to go away. So let's think of a bad consequence might be if you hit your brother or sister, you're going to lose time that you value or an item that you value for a certain amount of time. So one thing that I used was with my children when they were very young. My son loved working on the computer, loved playing on the computer from the time he was about 3 years old. So if he exhibited bad behaviors, he would lose computer time, and it straightened him up pretty fast. He didn't want to do that. Whereas now that they're teenagers, my daughter, the magic thing is cell phone. So if things are going on that I'm not okay with, we've got some bad behaviors going on, that cell phone goes away, and we get back to where we should be. So sometimes you have to find the magic thing. So that would be an example of a bad consequence. Okay, Piaget also believed in programmed or direct instruction, teaching with a sequence of learning activities and reinforcing correct responses. So a term that he used back then even was programming, which leads us to our next cognitive development theory is information processing theory. And if you're computer minded, this is going to really click for you. The information processing model is another way of examining and understanding how children develop cognitively, their brain development. This model conceptualizes children's mental process through the metaphor of a computer processing, encoding, storing, and decoding data. So let's look at this process here in the next graph. Information processing. Executive control processes. Again, think about a computer. The child is like the sensory register. That's where things are coming in through their eyes, through their ears, through all the senses and encoding. Their perception of what they're seeing then goes into short-term memory. And if we learn or go over that item a little bit more, it will then move to long-term memory, which is our goal with a lot of our learning. But let's not skip the process of continuing it on into active memories. And an example of that would be maybe we've taught a basic concept, we've gone on it over it several times. When you ask the children a question about it, they know the answer. Well, active memories is maybe when we go ahead and apply that information. So maybe we have talked about the difference between fruits and vegetables, and they've got it down. They can label what a fruit is, they can label what a vegetable is. Well, then into an active memory, maybe we cook something where we're using fruits or vegetables. It's an active process. They're really using that information. So then they're able to retrieve it and put it into working memory. And so this is where they remember that day, right? And they remember that concept. So if you think about the classes that you had in grade school, chances are the ones that you remember the most are the ones where you were doing something active and it was fun, right? You don't remember the worksheets so much, but you remember that one big fun activity. Okay, let's talk about how children learn. This is average student retention rates according to the type of learning on the learning pyramid and how it's occurring. So right here, right now, we're at the top of that pyramid. You're sitting in a lecture, you're listening to me talk, you're looking at some slides. So we could actually say we're lecturing, you're also reading a little bit that's on the slides, and you've got a little audio visual going on as well. So you're going to retain maybe about 20% of what you're sitting through right now. Now, if we were to add some type of demonstration to that, you would remember maybe 30%. So then if we were to have a discussion about it, which we do on our discussion boards, we'll continue some of these topics. You may then remember about 50%. If you practice doing it, 75%, but if you teach another person, that's about 90%. So you can tell from the learning pyramid that we actually learn the best, we retain the most when we're teaching others. And we can use that in an early childhood atmosphere as well by having children teach other children. It's a fantastic thing. So consider that when you're making lesson plans and planning activities. Okay, let's talk a little bit about math concepts in early childhood, because a lot of people think we don't do much, but we do. We go through numbers, operations, sets. We do a little pre-algebra by understanding patterns in shapes or sizes or numbers. We do a little geometry with our shapes and space, measurement through measuring sand and water at the sand and water table, problem solving. How can we solve that? It's mathematical, and we want to give the children the opportunity to solve these problems, give them time. And then data analysis and probability through charting, which we might use as an instructor, asking them questions, finding out how many people like a certain color, putting them into categories, and then drawing that out on the chart. Some science concepts that we do in early childhood. Biological sciences are huge with this age group. They love talking about the human body, about any animal out there, and of course about plants as well. Also, number 2, physical sciences, physics, chemistry, meteorology. You can draw all these into the classroom. Heavy science interest at this age. And recycling, they love recycling. So we can teach them about reusing, sorting, and we can also celebrate Earth Day with them, which is, I believe, in April of each year. So thinking about yourself in the classroom, this is an answer or a question that I would like you to answer in your summary if you're watching this video today. So think of a science course you have taken, and it may have been grade school, junior high, high school, college. Think of a science course that you've taken and tell me, what do you remember about the course? I want you to tell me what your biggest memory was about the course, okay? I love this quote, tell me and I forget, teach me and I remember, involve me and I learn, by Benjamin Franklin. So we want to be sure and focus on that final aspect of involving our children in the process, not just talking to them, right? All right, guys, we are to our final slide, and as far as questions goes, please email me, call me, text me, Facebook me. If you have any, I'd be glad to help out. Have a great week, everyone. Bye-bye.